All right, it is time to talk about how to find the surface area of different solids, and we are going to start with prisms. So first, just a reminder, we talked about this in one of the earlier videos this chapter, but the surface area of a solid is just the sum of the areas of the surfaces of the solid, meaning we've got a bunch of sides, we find the area of each side and we add them together. And so one way to do this is to think about each of these sides individually. And to do that, we would draw something called a net. So a net is basically just an unfolded version of a solid. So if we have this cube and we were to kind of take apart the box and flatten it out, it would look like this. We would have the 6 different sides and they'd form this shape of a cross. In order to find the surface area of the solid, we need to find the area of each of these rectangles here. So let's see an example of this. We've got a rectangular prism, 2 by 3 by 6. So let's draw the net. And here we've got 6 sides that correspond to the 6 sides here, right? We've got the left, the front, the right, the back, the top, and the bottom. So we just need to find the area of each of these rectangles, which we know how to do. This would be 6 times 2, 6 times 3, 6 times 2 again, 6 times 3 again, and then both at the top and the bottom here would be 3 times 2. So now we just need to add those together and get our surface area of 72 centimeters squared. Just like regular area, surface area is 2-dimensional. All area is 2-dimensional, so we have our unit squared. All right, so some vocabulary, some of which should be reviewed from one of the earlier videos as well. A prism has 2 bases that are parallel and congruent, and then it has lateral faces that connect the 2 bases together. So for example, in this prism right here, our 2 bases are the top and the bottom, the pentagons, right? They are congruent to each other, parallel to each other. So those are the bases. And then there's 5 rectangles that connect the pentagons. Those are the lateral faces. All right. There's also a formula we can use to find the area of a prism other than just drawing a net. And so this formula is surface area equals 2b plus bh, where b is the area of the base. So here, this triangle is one of our bases, the top and the bottom, 2b because there's 2 bases. And then the other part of our formula helps to find the area of those lateral faces, the perimeter times the height. So we've got perimeter of a base, that's what P is. We want to find the whole perimeter of this shape. And then the height is the measurement from top to bottom of the base, from base to base. Okay. So let's use this to find the surface area of this prism. Well, we have one measurement that's missing. We know our legs of our base, but we don't know our hypotenuse. So let's find that first using the Pythagorean theorem. We solve for C. So we've got that hypotenuse is 5. And now we need to think about what is the area of a base, what's the perimeter, and what's the height. For the area of the base, we'll use our formula for the area of a triangle. 1/2 base times height. So 1/2 3 times 4 gives us 6 centimeters squared. And then we need to add the perimeter times the height. Well, the perimeter is the perimeter of a base. We need to add the 3 plus 4 plus 5 here to get the perimeter of our triangle. And then our height is 7. So we plug all that into our formula. We do 2 times 6 plus 12 times 7, and we get our answer. And whenever you're taking assessments, please do know that all of these formulas will be given to you on your quiz, including the ones from last chapter, because we're going to continue to use those. As you saw, here we needed to use our formula for the area of a triangle, and we also used our formula for surface area of a prism. So these are formulas you don't have to memorize. They will be given to you. All right, let's look at one more. Here we've got a prism where the bases are regular hexagons. So the first thing we need to do is figure out what our apothem is so we can find the area of our base. So first off, we've got hexagons. Hopefully you remember that when we have a hexagon, we end up with a 30, 60, 90 triangle in here. And we end up with an apothem of 3√3 meters. So if you don't remember how to do that, let me know and I can show you. But this measurement of the apothem would be 3.3 or 3 times the square root of 3 meters. Of course, we need our perimeter to both calculate the area of a hexagon and also to calculate our surface area. That's 36 because we got 6 sides that are each 6 meters. So let's find our area of the hexagon. We'll do 1/2 the apothem times the perimeter We simplify this down. We do 1/2 times 3 times 36. That's 54. So we get 54√3. That's our area of one of the bases. And now we need to plug all this stuff into our formula. 2b plus perimeter times height. Perimeter of 36, height of 12. If we do all of this, we get 128 times the square root of 3 plus 36 times 12. We get this number. This would be an exact answer. If we want an approximate answer, we can plug that into our calculator and get 619.06 meters squared.